Welcome all. The next talk is Home Automation Using Free Software by Abhas Abhinav. Abhas is a hacker, entrepreneur, free software activist, and founder of Deeproot Linux and Mostly Harmless. Abhas, the stage is all yours now.
Thank you so much. So good afternoon, everyone. I'm going to be talking about home automation using free software, and what I intend to do is not just talk about it in an abstract manner using slides, but also show you this whole thing working very quickly. Let's just look at a larger level picture about why all of this matters at all. Why are we even discussing this? Well, I would say the first thing about using electronics and networks to control stuff is that it's cool. And if you've seen science fiction movies in the 80s, 90s, this is all we wanted to do when we grew up, I would say. So it's possible to do that, of course. The question is not about the possibility of doing it, but how to do that using free software. What are the challenges with off-the-shelf products that we generally get in the market? And the market is full of products like these. I'll define what sort of products we're talking about. So before we actually, go into these things, I want to give you a quick demo of what I'm going to be talking about. So one of the simplest things that we have in any home is a switch, right? We put it on to put on a light or a fan or a power outlet. Now what I have here are multiple types of switches. So there are switches like these, which control up to 4 loads. We have other switches like these, which are actually power meters. So you cannot, so apart from being able to control an outlet and being able to control a load using that, you can also monitor the power consumption. You could know how much power you're consuming across all your outlets in your home, right? Then we have tube lights. Now, one might question that, what's the value in a tube light? I'd like to show you something very quickly. So today, a lot of these tube lights that you get in the market are network enabled. I mean, they connect to a wireless network. And hence, what they enable us to do is control them, control their colors, and control their brightness and those sort of things. So I have 2 types of lights here. I have a simple light which lets me change the brightness, which is only white. So you can see this one. It has 2 types of LEDs, yellow and white, and then we can mix that. We can switch it off and on, and we can increase the brightness, change the color, how yellow we want it to be, for example. Then we have a light here, which is an RGB light. What that enables us to do is, it enables us to change its colors. We can make it any color we want. And we can have it pulsate between multiple colors as well, right? Apart from this, there are lamps. So we have, lamps here. I forgot to get a couple of other ones. But so now we can have a lot of such lamps which we can also control. Now I'll give you a quick demo of how to control a lamp like that. So yeah, it's here. So we can, like I said, you can, so we have an animation running here, an animation of the sense that it shows different colors at different levels of the lamp, right? So that is controlled by the effects that we have. So we can have multiple types of effects. And we can, so what's happening is there is a controller here which is connected to the wireless network that we have here. And via that controller, via HTTP API, we can control all these things very easily. So there's stuff like that. One of the most important things is our ability to control the network. Now, as you might have understood, all of these devices that we have lights or switches or lamps. All of these connect to a network, to a wireless network most of the times. And unless we are able to control that network, it would be sometimes very difficult to even debug what's happening or be able to control what's happening. So one of the most critical components of building this is to use the OpenWRT operating system on a router like this, and then build the home automation system, because you are going to be able to look at all aspects of the network, on the device as well as, on the wireless side. I'll come to this a little later on. Right. Now, the most critical, so the question that we started with is, isn't this problem that's been solved many times? If you've looked at online stores or even physical stores, you've seen Philips selling products like these. These are very common, actually. There are a lot of companies who import and build and manufacture these products and sell it. But there are serious problems in each and every one of those products. Let me show you the typical workflow of a so-called smart device. Now, this is the picture I took from a sort of a installation manual that came with one of these products. And what does it show you? It shows you that the device here talks to the network over Wi-Fi, and then it connects to the server over the internet, and that to control this switch, you need a mobile app which talks to their server over the internet as well, right? So you could be standing right next to that switch. You could be standing right next to that light, but your ability to control it depends on multiple things. The server has to be online, internet has to be working, and when you actually toggle that light or control it, you're not sending a command to that device directly. You're sending a command to the server, and the server sends a command to the device. So all the products that are available on the internet or anywhere in India also, they have exactly the same workflow. Okay, now this is the problem that we are trying to solve here. And there are two aspects of this problem. The first thing is, look at this mobile app part, the last part there. Most of these manufacturers mandate that you use their mobile app. And their mobile app requires you to share a lot of information about yourself. You need to tell them your phone number, your email address, your name, your location, your GPS location. You need to tell that app your Wi-Fi network password and SSID. And then you can use that app to configure the device and start using it. Right? So these are some screenshots that I've taken of that app, just to show, number one, what are the conditions that you have to agree to, the first two screenshots here, the sort of conditions that you have to agree to just to be able to use that application. Okay? If you refuse to agree to these, you can't use the app, and hence you can't use the device. So that's one aspect. The second is the sheer amount of information that you need to share with the application, and hence with the company which built that device and application, right? So, well, it angers me to be, if somebody demands these things as a condition for me to use a device that they have manufactured and distributed. And I'm sure all of us would feel equally angry about it. Now, let's look at another aspect. This is traffic that I captured using Wireshark from the router. Another reason why you want to control the router, so that you can SSH into it and run TCP dump, and then redirect that output to Wireshark so that you can analyze the traffic. I wanted to know what type of traffic the device sends to the server, to the mobile app, what ports it's using, where those servers are located, and who operates those servers, based on the IP address that that data is being sent to. So I would invite you to look at this in greater detail on my computer afterwards, but there are IP addresses of all sorts here. All of them are not in India, first of all. Secondly, there is a lot of information that goes out, and if you look at the screenshot on the top in the middle, that's the packet that I opened up, and it has my wireless details in plain text. So the point is that a proprietary application built by somebody else has access to all this information, and I'm agreeing to a contract, I'm agreeing to conditions that I'm not free to negotiate, right? I didn't get a chance to negotiate those conditions, but I have to agree to use those. And if you look at the scale at which these devices are manufactured and sold, it's probably in tens of millions of devices. If you have 200 outlets in your home, you would probably need maybe 50 such devices. And there are multiple devices. Today, a lot of builders would incorporate these devices into their buildings when they sell it to you, right? So the challenges are these. Everyone who's buying and using these products off the shelf, they are being surveilled to this level. Most of us don't care about it, maybe, or most of us are not aware of it. But we do want the value that you get out of having these things, right, in the first place. Now, so the problem is, this is the problem that we're trying to solve. The first problem is, of course, that there is proprietary software everywhere. We're using a mobile app, which is proprietary. We're using firmware. There's firmware on the device, which is all proprietary. None of these work without internet access by default. And in my view, the ability of a device to work without internet access is critical for our ability to control it. I cannot control a device that refuses to work without internet access, because that's a non-feature in a way, right? Because why does it need internet access? Because it needs to contact a server on the internet, which means that there is somebody else who's operating a server which exerts some amount of control on a device which affects my life in so many ways. They require malware on your phone to control it. There is no other way to control that device. Yes, you could go and press a button like this, but then what's the point of having these if you have to go and press a button, right? The only other way to control that switch from a distance, it could be within the house or from somewhere else that you are, would be to use the mobile app. And we already saw the things that the mobile app does and the information that it takes from us. And there is a part in that condition about sharing that information with third parties. It's very clearly written that what information they share and with what sort of third parties they share it with, right? So that's another information, that's another challenge with how this problem is solved, right? And moreover, we've just become consumers of these devices. We have no stake in how these work, and we have no stake in how these affect our lives, right? And there is definitely no opportunity to play with them. And play is important because if you're going to get ideas, if you're going to be creative about how we do a lot of things in our lives, we have to choose the hardware carefully to do those things. Unless we choose the hardware that affects our lives carefully, we will not be able to run our own software on it, and hence we will not be able to control those devices. So in a sense, what I believe is that the ownership, our sense of ownership of devices stems from our ability to control them, right? When you don't have the source code to the software that you're running on a device, you have no control on what the device does, and hence there is no ownership, right? So I could have paid for it, I could have paid for the device, and I might consider that I own it, but I don't control it, right? I'm dependent on somebody else's computer to put on a switch in my house. As long as I have that sort of dependency, I don't really own the device. The device is owned by the people who build that software and who control that server. So what we are going to talk about is the process of liberating these devices. We're going to talk about what it takes to liberate them, and how we can achieve all these goals without succumbing to these anti-features, without having to compromise on all these sort of things that we do, right? Okay, so let's go step by step. I'm just going to outline, three very simple steps, and I'm going to go into detail on all of them. The first step, own your network. because all of these are going to connect to your network, it's imperative that you have absolute control on your network. And one of the best ways of having that control, or rather the best way of having that control, is to flash OpenWRT on an accessible router that you might be able to purchase or use. Why? Like I explained earlier, our ability to just get root access so that we can run TCP dump so that we can see what traffic is getting transacted on our network, that itself is a reason to be able to control it, or to have this need to control it. So what I typically recommend, and what I typically do myself, is that if you've seen the stall that we had a lot of routers there. So this is a similar and very low-cost router that we're running here. And so I'll show you what that router looks like. Yeah. So this is the router homepage. And I have a very clear list of all the devices which are connected to my network. And I know their IP addresses. So the point is, using a free software operating system on your router does not make it more difficult to use your router. The router's job is very simple. It has to run a network. It has to provide all sorts of services on that network, DHCP, DNS, maybe NTP, and so on. And the point is that using OpenWRT does not make it more difficult for you to do all these things. So if you care about Debian and you care about GNU Linux and free software, there is really no reason that you should ever run a proprietary OS on your router. Because, well, one of the things that happens when you do that, I have seen that myself, is that the router can potentially send DNS queries that you make to its own server. And hence, the manufacturer of that router can potentially have a huge database of all the sort of websites that people visit from various countries and ISPs and networks, right? You can change that, of course, but then the point is about transparency. You might change a setting. How do you know that the setting is actually getting applied? So that's the general problem with proprietary software, right? That of trust. How do you trust a proprietary tool to do what it says that it's doing? It's impossible for us to know that it's actually doing that, and it's futile to spend time trying to trace it, right? If you just run a free software tool, you can implicitly trust it, right? So this is what we're running here. Now, all these devices that we have for home automation, they run very tiny microcontrollers inside them. These are Wi-Fi microcontrollers, and I mean, these microcontrollers are extremely cheap. Most of them cost in the range of 150 to 200 rupees, in fact. And the best thing about these devices is that the manufacturer enables us to flash our own firmware in them. Now, why would a manufacturer do that? I mean, they don't really have a need to do that, right? So I have a lot of devices with me which are unflashed, and we can open these up as well. But what happens on these devices is that they leave, so they need to have certain pins on the board to program the microcontroller in the first place, right? And fortunately, they leave those pins populated on these products when they ship it. So I think that's the best thing that they do, because see, that manufacturer is going to recover their money, the cost of manufacturing it, when they have sold it. Now, if you flash your own firmware on it, it doesn't spoil their business case, right? They have already earned their money. Whether you run their firmware or not, they have earned their money which they wanted to earn out of selling it, right? Fortunately, they allow you to flash stuff on it. So there's a very large community of developers who bought a very wide variety of devices. They've opened them up, they've taken pictures, and they have documented the process of flashing free software firmware on them and hence liberating them, right? So one of the tools that I'm using here on these devices is a tool called Tasmota. So So this is the tool that I'm running on all these devices. And this project has an extremely large database of devices that you can browse. So if you want to know what sort of device to purchase, one of the ways is to go to their device repository and check which devices are easy to flash and liberate, and then buy those devices, right? Now, this information is public, right? But like I said, the problem is people don't think about it like this. They don't think that if we are going to purchase this device, would we still retain the liberty to flash our own firmware on it? So they might just use it, the way it's shipped. But for example, they have a section for India, and they have specifically documented devices which are sold in India. Like there are tube lights from Wipro and Polycab, which I have over here. And that's the best part, because now if you purchase that tube light, you know exactly what the pinout of the microcontroller looks like, and the process of flashing it is documented. Yes, the challenge here remains that we have to open it up. We have to take the tube light apart. We have to solder 5 wires, and then we get the ability to flash. So that is a bottleneck. I mean, the manufacturer is not going to ship the tube light with a small port on the side, so that they're not going to make it extremely easy for us to flash these things. There is a challenge involved there where we have to open things up, and then it's quite possible that we might do something wrong and it might not work. But the opportunity remains, right? So if we build our skills such that we can do such things, then when we buy these devices, we don't have to put up with the proprietary firmware inside them, right? So that is the second part. So I'll take you through sort of a tour of all the devices that I'm using here, and I will show you the process of flashing it. And then, if we have time later, we could actually do that with a live device as well. The third thing, why do people buy these devices and how do they use it? The next thing is the mobile app, right? So what we are using here is a tool called Home Assistant. It's a free software tool. There is an extremely large community of people who contribute to that, who extend it, integrate all sorts of other systems to it. And the mobile app which corresponds to that Home Assistant tool is also free software. So you can get it on F-Droid, and that's the best way to do it. So we're going to look at what features Home Assistant offers us and how we can integrate these devices with Home Assistant. So let me change my display. Okay. So the first thing is, let me show you what the firmware looks like. So this is the firmware. So this is so what happens is, on these devices, like I said, there is a wireless microcontroller, and there is a web interface which is running on it. So once it connects to a network, you can just access the web interface to do simple things. So if I want to switch off something, I switch off the lamp. I can do it via the web interface. I don't need to do any integration at all. But then the challenge is you have to remember so many IP addresses or host names, and then you'll have to visit them individually, right? So that doesn't make sense. But that option is there. So again, imagine the features that the microcontroller has. Like I said, it's an extremely tiny, extremely cheap microcontroller, but it runs enough software to run a web server on its on its wireless interface, which allows us to control and do these things. This tool, Tasmota, it has a serial console interface. So if you want to talk to it via various commands, and these are which are documented on its in its documentation, you could actually do that. There are all sorts of information that you can query over serial, and as you can see here, the information that it returns is in the JSON format. So it's easy to programmatically do something with that information, right? So this device was manufactured by a company called Sonoff, and generally, I would say almost all Sonoff devices are very easy to liberate, and they're very well supported by Tasmota, and not just Tasmota, there are other softwares as well. Now this tool that we have here, these switches that we have here, they are special. They're special in the sense that this one doesn't have any relays in it. This is just a controller. This has 4 relays in it, and it talks to, so you can have up to 22 of these modules in your house. And the way it talks to them is over a protocol called RS485, Modbus, right? So how does it get information about power consumption? So you see L1 here, sorry. So L1 is the first relay, and we have these things connected to the output of the first relay here. Now, it gets this information over Modbus. So there is no microcontroller here. This is just, all we have is, we have current sensors which measure power consumption, how much current is being drawn and what is the voltage, and then we can compute the power factor and so on. And this is the controller for that. So like I said, you can daisy chain so many of those, and as a protocol, Modbus is a very reliable protocol. It's very popular in industries when you have to talk to various machines, right? So this is the thing. Now, the way Tasmota works is, the firmware that you install in each of the devices is exactly the same. How do you know what type of device you're flashing it into? There is this concept of templates. So what you do is, you go and paste a template here, and that configures the firmware for the device that you have flashed it on. So how do you get these templates? If you look at the Tasmota documentation, you have the templates documented here, right? So these are just the way the pins are mapped. That's all it represents. There are a lot of I/O pins. Which pin does what is what this fragment of code tells us. There are other ways of also controlling this. We could go and manually do that if we wanted. We could go and map those pins ourselves. But we don't need to do that because these things are very well documented. Right? Okay. The same software is running on the LED button, this one. So because it knows that it's running on a tube light, it provides us these sliders to control it, right? So one of the sliders is brightness, and the other is the color, right? So whether it's using the white LEDs or the yellow LEDs, and you can mix them. So this is very similar. If you go to configuration and other, you can see the template that it has, and that template would have been documented here. So what we are using is this product from Polycab. So this is the template for it. Similarly, for the RGB light. Now, one thing I was showing you was that the pinout for these tube lights or these devices is documented. But that's not the only way to control them, right? That's not the only way. You can actually take this microcontroller out and put in your own microcontroller there. right? So I'll show you some pictures of how I actually build these devices. Just give me a moment. All right. So I'll show you the power meter. Now this is the board of the power meter. It's actually a very, very powerful board. It has Ethernet as well. It has 2 microcontrollers, in fact. Now, when we flash free software firmware on it, we actually lose the ability to talk to the second microcontroller which is there, because that microcontroller runs proprietary software. But the one that controls it over the network is the one which runs our firmware. Okay, sure. Now, what the manufacturer does is, they give us these, like I was showing you, they give us these pins. So these are the 3 volt, RX, TX, the serial port pins and the ground pin. So those are the 4 pins that we need to talk to this microcontroller, this ESP32 microcontroller, and then be able to flash stuff onto it. So this is one of the ways I do it, by soldering these wires temporarily, and once it's flashed, then you can desolder these. So this is for the power meter. The tube light, so for the tube light, what I did is a little different. I could not flash firmware on it, onto the microcontroller that shipped with it. I could not flash onto it. I was not able to talk to it. So what I did is I removed that microcontroller. And then, so this is the one that came with it, and I was not able to program it. I took a generic, a small VMOS ESP8266. I soldered wires onto it, and then I soldered these wires onto that tube light controller, right? So basically it looks like this finally. And then I have put all that into the tube light now. But see, that is also a way to control it. When you can't flash stuff onto the controller they ship. Now this controller is similar to the one that we have here. It's very similar. But sometimes you might not be able to program it. You might not be able to talk to it for a variety of reasons. And hence, a good solution is to also replace that controller, right? Which means more work for us, but it does not limit our ability to control that device. So what I'm trying to show you is that a device manufacturer might want to defeat us. Well, that's not their goal. Their goal is not to make it difficult for us to flash. They don't think that people are going to do these things. All these are amazing hacks that the community has built. But they don't actually have to go out of the way to make these things easy for us, right? Hence, if we know what's being done there, we can actually find workarounds like this, because we are very clear that we need to be able to control them completely, right? So basically this is what I did. I put a lot of glue so that those wires don't come out. And then it worked well. Now similarly, these are the controllers of this jewel color, the white tube light. Now as you can see here, there are 2 types of LEDs here, right? There are what is called natural white ones, and there are yellow ones. Now, can anybody spot the difference in these controllers? If you just look at it, do they look similar? Or don't they look similar? What difference do you see? So they're very similar. The components, the layout, everything is very similar. But these are from two different manufacturers. One is from Wipro and the other is from Polycab. One is sold for 600 rupees and another is sold for 1000 rupees. But there is no real difference. They are both manufactured by the same company in China. And they both run the same firmware on it, which is just branded differently. So when I opened these up, that was a huge lesson for me, because we know now that there is no real difference in electronics. If two companies charge us differentially for the same hardware, that's about their marketing, distribution, all those costs. It's not necessarily about the value of what they're selling you. And since you know that both of them have the same stuff inside, you could actually purchase whichever is cheaper or more accessible. So everything is the same in these. So again, here there are multiple ways we can. I have a picture of that. So we can solder wires onto it and program them. Now look at this plug. This is a plug. I have it with me. This is a plug. You can just plug it into a wall switch and you can control it. The best part is they have used a more conventional microcontroller inside it. They have left all the pins that we need. You see these 4 pins here? They have left those pins right there very significantly for us. So, I mean, if everyone built hardware like this, our job of being able to run our own firmware on it would be so simple, right? Similarly, I could quickly show you bulbs. So this is a bulb. This is an RGB bulb. So this is the controller for it. There's a lot of power circuitry here. And then there is a microcontroller here, which the Wi-Fi microcontroller. So what happens is, this board here on the top, the round board, that has multiple types of LEDs. It has very powerful white LEDs, which give you plain white light, and then it has the RGB LEDs for changing the color. And then you can mix these to change the brightness of the bulb. Now, so here what I did is, I again could not program the microcontroller the way it was plugged into the board on it. And this time what I did is, I took another microcontroller, this one, this is an ESP8266. I programmed it, and then I soldered it directly onto that board. I made a few mistakes. I managed to actually pull up some of the tracks, but so finally this is how I had to assemble it, but it worked. I was able to control it. I was able to. Now it's very ugly, of course. I can't really deploy it anywhere. It's like your development environment for your source code. I can't deploy it, but I know what we can do with it now, right? And if you take apart multiple types of bulbs, you will see that they have exactly the same system inside them. So, for example, this is a plain bulb. You can see that it has just 2 types of LEDs here, yellow and white. And these are not meant to be opened up. The process of opening up a bulb actually destroys it. You can't put it back together. Again, you understand, they're not building these devices to be repaired or to be hacked, right? And this is, so, but you can do these things. I mean, that's all I'm trying to show you. Okay, so we have about 5 minutes. I wanted to show you the Home Assistant system very quickly now. Okay, so Home Assistant is a very, very complex system. It can do all sorts of things for us. For example, you want to turn on the lights or you want to turn off the lights when you leave your office or your home. How do you do that? How does the system know that you are at home? Well, what I've done is I've created an integration between Home Assistant and OpenWRT. When my phone connects to my wireless network, I can use that as a trigger to signify that I'm home. And as a part of an automation script inside Home Assistant, I can put on lights. I can put on music. I can put on the geyser. I can do all sorts of things. Or I could put off lights. So why go and switch off lights on your own when these systems can do it for you? Don't spend that energy on putting on lights or putting off lights. So there are integrations like that. So we can create all types of dashboards. You know, on this dashboard, I have some simple toggle switches like these. And this is a toggle switch. I just use a different icon for it, for these power meter relays. We can create multiple types of dashboards. Now I've created a dashboard for the phone. Now on my phone, I have the Home Assistant application installed. And obviously the application now has access to all types of sensors that my phone has. My phone has a light sensor, so Home Assistant can get that data. And you have to give permissions to that. It's not that it can get all these sensor values by default. You have to tell which sensor values you actually want it to be able to. But now I can get all sorts of information about my phone, right? And I could log these. So it's not just that we are able to show these on dashboards, but for example, this is a dashboard which shows the current power consumption. I could also look at that value over time, right? So this is since morning, since 9 o'clock in the morning. You can see when it was not on, when I was transporting it from the room to here. And so you get to see these things, right? In fact, if we deploy this well, Home Assistant has a very nice energy usage dashboard, which can, completely give us complete idea about our energy consumption. I mean, if you're using solar, then you can compensate for that as well. Similarly, when you talk to OpenWRT, you can use it as a device tracker. How do you know somebody is home? If their phone is connected, you know they are home. So there are ways of doing that. If you just looked at the integration, because a lot of these integrations are with proprietary systems as well. But you can, for example, get information from your UPS. So if you have APC UPSG running to tell you about the load on your UPS, you can get that information, and you could turn off your lights when there is no power, right? Or when the battery of the UPS is low. So there are hundreds of integrations here. And that is what makes this system extremely interesting, because now you can connect all of these things together in one place. You could build a matrix bot, and I've been trying to do that. Okay, I don't have it running here. So I integrated Home Assistant with a matrix server. I created a bot account for it, and then I was trying to have it send stuff to a room. So that's not working, but I can do that. I can send a message to the bot to switch on a light or switch off a light, or to check if the lights are on, right? Similarly, if you wanted to put up a nice display with just basic information, then you have the ability to create panels and dashboards like this. So I would invite you to come down and check these things out firsthand. And there's a lot more hardware with me to show you what's there inside these things. Of course, I also have the same sort of controller running here on my jeans. So it's I'm powering it using my phone with a microcontroller, and I have that integrated onto Home Assistant as well. So now, if there are questions, I would love to answer some of the questions. And thank you so much for being here and for caring about home automation using free software.
We are just short on time, so please keep your questions short.
How about warranties from the manufacturers?
Okay, I don't think they actually offer any warranty. So when you change the firmware, you open it up, you solder stuff to it, I am guessing that it voids the warranty. Having said that, these devices are extremely resilient to various things. In fact, yesterday I managed to blow up a tube light controller because I shorted 2 terminals. It did not affect the relay. It did not affect the power strip and the relay. The tube light doesn't work, but these things continue to work. So these components are actually pretty high quality, I feel. I really don't think you would go back to somebody asking them for warranty or replacement after having hacked on it. That holds true for phones also. I'm sure that holds true for routers as well, right? When you flash your firmware on it. So the good thing is they don't stop you from doing it, but then expecting them to give you warranty and support after you have done what you want to do is, I don't think that's right.
The time we had is over. So for now, thanks Abhas for the talk. But we have tea break right after this. So for 15-20 minutes, we'll have the stuff here so you can come and ask your question after the talk. So thanks Abhas.
Thank you so much.